Hello students, in previous class we already discussed what is circular motion and the different motion parameters related to circular motion, that is angular velocity, angular displacement and angular acceleration, and the relation between angular velocity or angular displacement theta and that is of angular velocity omega and angular acceleration alpha, and how they are related to their linear correspondence, like the relation between linear displacement s equal to r theta and that is linear velocity v equal to r omega. Clear? And in vector form we can write the linear displacement s equal to theta cross r and the linear velocity v vector equal to omega cross r vector, where r vector is known as what? The radial vector or the position vector of the particle. Which is executing circular motion. Okay, and the angular acceleration is related to the linear acceleration, like we already established the relation in vector form, that the total, if a particle executing circular motion in a circular path of radius r, so at any instant the linear velocity is tangent to that point, and this is the radial vector or position vector of the particle at that instant, and the angle sustained by the position vector will be the angular displacement, and the acceleration of the particle which is performing circular motion, the total linear acceleration is equal to what? The sum of two components, one is a tangential and the other one is a normal or a radial. We can say that it is a normal or a radial. We already established the relation between them, where the total linear acceleration is equal to alpha vector cross r vector, which is also known as the tangential vector acceleration, plus omega vector cross v vector, which is known as the a radial or a normal. So what is a tangential and what is a radial or a normal acceleration? So these are the two components of the total linear acceleration of a particle which is executing circular motion. So as we already know, if a body is moving in certain direction with certain velocity v, then if that body has some acceleration along the direction of velocity, let a tangential, which is tangent to the direction of velocity or along the direction of velocity, then this acceleration cause to change the magnitude of velocity only. That means the acceleration which is along the direction of velocity can responsible only to change the magnitude of velocity. That means the tangential acceleration or the acceleration which is along the direction of velocity can only change the speed. Okay, because the magnitude of velocity is known as what? Speed. So if the acceleration is along the direction of velocity, then it only responsible to change the speed, not the direction. But if there is a acceleration which is acting normal or perpendicular to the direction of velocity, here in that case this is known as the a perpendicular or a radial, then that acceleration is only responsible to change the direction of velocity. So the a normal acceleration change only the direction of velocity. Okay, if the acceleration has two components, one is along the direction of velocity and the other one is perpendicular to the direction of velocity, then the magnitude of velocity changes as well as the direction of velocity changes. So here the total linear acceleration has two components, one is a tangential, that is which is acts along the direction of velocity of the particle which is performing circular motion, and the other component which is known as a radial or a normal, which is acting perpendicular to the direction of velocity of the particle which is performing circular motion. So this component of the total linear acceleration which is acting perpendicular if here is the direction of velocity, then the tangential acceleration acts along the direction of velocity, and the acceleration which is perpendicular to the velocity is known as a radial. So this is the direction of a radial. Clear? So the component of the linear acceleration which is along the direction of velocity of the particle is known as a tangential, which is responsible to change what? The speed of the particle or the magnitude of velocity, and the component of the linear acceleration which is acts perpendicular to the direction of velocity is responsible to what? Change the direction of velocity. Clear? So the net acceleration has two components. One is along the direction of velocity or tangentially acts along the direction of velocity, and the other one is acts perpendicular to the direction of velocity. Clear? So these two components are known as two different accelerations. The component of the net linear acceleration which is acting along the direction of velocity is known as tangential acceleration. Here AT is known as tangential acceleration, and the component of the net linear acceleration which is acting along the radius or normal is known as centripetal acceleration. Okay. So the total linear acceleration of a particle executing circular motion has two components. One is along the direction of velocity, that is known as tangential acceleration, which is defined as alpha cross r or r alpha, and the other one is which is acting normal to the direction of velocity, that is known as radial acceleration, or which is defined as v omega cross v or v omega. Okay. So first of all we have to know what is radial acceleration or centripetal acceleration. This is known as centripetal acceleration. It is the acceleration of the body executing circular motion which is normal to the direction of linear velocity of the body. Okay, and it acts along the radius of the circular path towards the center. Okay, and this is defined as a radial, or this can be also known as a centripetal, which can be defined as in vector form omega cross v, or its magnitude can be written as v omega. Clear? Or as we know, v is equal to r omega. So this implies the centripetal acceleration will be how much? R omega square, or this can be also known as v square by r if omega written as v by r. Clear? So this is the expression for what, or the definition of centripetal acceleration. Clear? So next is the tangential acceleration. It is denoted by AT. So it is the acceleration of a body executing circular motion which is along the direction of linear velocity of the body. Okay, so it is the acceleration of a body executing circular motion which is along the direction of linear velocity of the body. Clear? And it can be defined as a tangential vector can be defined as alpha vector cross r vector, where is alpha is known as the angular acceleration and r is the position vector radial vector of the body, or in magnitude the A tangential mod equal to r alpha. Okay. Clear? So these are the two type of acceleration can be present in case of circular motion. So depending upon the acceleration of a particle executing circular motion, the circular motion can be categorized into two types. Okay, one is uniform circular motion, okay, remember UCM, uniform circular motion, and the other one is non-uniform circular motion. Okay, so what is uniform circular motion and what is non-uniform circular motion? We already know when a body is executing a motion in such a way that its distance from a fixed point remain constant, then that type of motion is circular motion. And in circular motion, the body must have angular displacement, angular velocity and angular acceleration, and the total linear acceleration of the body can be divided into two components, one along the direction of linear velocity and the other one is perpendicular to the direction of linear velocity, and the component which is along the direction of linear velocity is able to change the magnitude or change the speed, and the other component which is acting perpendicular to the direction of linear velocity changes the direction of the particle. So as in case of a circular motion, the direction of velocity changes at each and every instant, so it must have the perpendicular component of the linear acceleration or the acceleration which acts along the radius, that is radial acceleration. But maybe the speed of the particle changes or may not changes. That means the speed of the particle may remain constant or the speed of particle may changes, but the direction of the velocity of the particle changes at each and every instant. So it is compulsory that if a body is executing circular motion, then its direction of the velocity changes at each and every instant. That means it must require a acceleration which is acting perpendicular to the direction of linear velocity. That means if a body is executing circular motion, then it must possess a radial acceleration. But if there is no tangential acceleration, then the speed of the particle does not change, it remains constant. So depending upon the tangential acceleration, the circular motion can be uniform or it can be non-uniform. So what is uniform circular motion? If the speed remains constant, okay, if the speed of the particle is constant, that means the magnitude of velocity is what? Constant. Then the circular motion is said to be what? Uniform circular motion. Same as that of in case of non-uniform, if the speed is not constant. Not constant, that means the magnitude of velocity is not constant, then the circular motion is said to be non-uniform circular motion. But in both uniform circular motion and non-uniform circular motion, these two motion are accelerating motion. Clear? here speed is constant, here speed is not constant, but in both the case the velocity changes. So here v vector changes, and in this case also the velocity vector changes. Okay, so this is also accelerating motion, and this one also accelerating motion. Okay, you have to remember the points for uniform and non-uniform circular motion. Clear? So the next point, as here velocity remain constant, so derivative of change of speed is equal to 0. Clear? So if this equal to 0, so r alpha, the a tangential magnitude which is equal to r alpha is equal to 0. So this implies, as r can't be 0 because the radius of the circular path is fixed and constant, so this implies alpha equal to 0. Clear? So you have to remember, in case of uniform circular motion, it does not have any angular acceleration. Clear? Angular acceleration or alpha equal to 0, as the tangential acceleration equal to 0. Clear? Because there is no change in the speed. So if speed is not changing, that means there is no acceleration along the direction of velocity, which is equal to the tangential acceleration. That's why the tangential acceleration equal to 0, so alpha equal to 0. So in this case, as speed is constant, so kinetic energy also constant because it is half mv square. So kinetic energy, which equal to half m v magnitude square, is also constant. Clear? But the momentum is a vector quantity which depends upon velocity, so it changes. Clear? So you have to remember all these points. In uniform circular motion, speed is constant but velocity changes, so the body is accelerating motion. The rate of change of speed d by dt of v mod is 0. Clear? Because it is remain constant, so dv by dt mod is 0. So a tangential which is equal to r alpha is equal to 0. So as r can't be 0, so alpha equal to 0. That means the angular acceleration for a uniform circular motion is 0. And as speed remain constant, so the kinetic energy is also constant, but the momentum changes. Clear? So in this case, in non-uniform circular motion, as magnitude of speed is not constant, so dv mod by dt is not equal to 0. So a tangential is equal to how much? R alpha is there, it's not equal to 0. So this implies alpha is not equal to 0. So in non-uniform circular motion, the angular acceleration is not equal to 0. Here kinetic energy, which is equal to half m v mod square, is also not constant. It varies, as at each and every point the speed also changes, so the kinetic energy also changes. And for potential momentum, this is also changes, mv vector also changes. Clear? So you have to remember all these points regarding uniform circular motion and non-uniform circular motion. So in both the cases, the motion is accelerating. Here the speed constant, that's why kinetic energy constant, but momentum varies. And as speed constant, so tangential acceleration is 0, that's why the angular acceleration of the body is 0. Here as speed varies, so as well as velocity varies, so as speed varies, so tangential acceleration is not equal to 0, so alpha or angular acceleration of the body is not equal to 0. So kinetic energy is also not constant because speed changes with respect to time, but and as the direction and magnitude both changes, so obviously the velocity changes, so momentum of the body is also changes with respect to time. Clear? So this is what uniform circular motion and non-uniform circular motion, which is basically depends upon what? If the speed constant, then the motion is completely uniform circular. If the speed changes, then the circular motion is non-uniform circular motion. Clear? So you have to remember all these points regarding uniform circular motion and non-uniform circular motion, which will be helpful for you to solving many conceptual questions and numerical problems. Okay, so next we are going to discuss about the centripetal force. Okay. Denoted by Fc. So what is centripetal force? As we know, if a body is executing circular motion, then it must have an acceleration along the direction of radius or perpendicular to the direction of linear velocity, because in circular motion each and every instant the direction of motion of the particle changes. So according to the Newton's first law, to change the direction there must be a force is responsible to change the direction or change the path. So if the body is initially at this point, it has a velocity along this direction, but if it is executing circular motion, then at the next instant its velocity changes. Similarly, for each and every instant the direction of motion of the body changes. So as each and every instant the direction of motion of the body changes, then there must be a force exist which is responsible to change the direction. Clear? And that force is acting perpendicular to the direction of motion of the particle. Clear? And if here is a force and the particle has some mass m, then there is a acceleration must be along this direction of force, due to which the particle is changing, and that acceleration we already studied is known as centripetal acceleration. And due to that centripetal acceleration, the force which is acting on the particle towards the center of the circular path along the radius is known as centripetal force. Clear? So the centripetal force is what? Centripetal force is the force which is responsible to maintain the circular motion of a body, or to provide the required centripetal acceleration to a body, because centripetal acceleration is must for a circular motion. Tangential acceleration may or may not be there, because we already studied if velocity magnitude remain constant, that means speed is not changing, the circular motion is uniform, then the tangential acceleration will be 0. So tangential acceleration may or may not be compulsory for executing circular motion, but for circular motion the normal acceleration or the radial acceleration is must, otherwise the direction of motion can be changed. So to give a acceleration perpendicular to the direction of velocity, it must require a force, because force causes acceleration. So the force which produced the centripetal acceleration is known as what? Centripetal force. So the force can be any type of force, but if that force is responsible to provide the required centripetal acceleration during the circular motion of a body, then that force is known as what? Centripetal force. So what is centripetal force? It is the force which is responsible to provide the centripetal acceleration of a body, and it acts on the body towards the center along the radius. Clear? So in basic or generally, what is centripetal force? It is the force which acts on a body executing circular motion it's the force which acts on a body executing circular motion along the radius and towards the center. It provides the required centripetal acceleration for executing the circular motion. Okay, so what is centripetal force? It is the force which acts on a body executing circular motion along the radius and towards the center. Clear? You have to remember this. It's the force which acts on a body executing circular motion along the radius and towards the center. Okay, and it provides what? The required centripetal acceleration for executing the circular motion, because it is necessary to have a centripetal acceleration for executing a circular motion. If there is no centripetal acceleration, then the circular motion is not possible. Clear? Because we already studied, for circular motion at each and every instant the direction of motion changes. So to change the direction of motion, it must possess a acceleration which is along the direction of change in velocity. That's why for circular motion the centripetal acceleration is necessary, and the force which provides that required centripetal acceleration is known as what? Centripetal force. And the centripetal force is always acts along the radius and towards the center, same as that of what? The direction of centripetal acceleration, as we already studied before. Clear? So this is known as the centripetal force. Clear? So this centripetal force can be any type of force. For example, if a metallic bob is fixed with a string, okay, and this bob is executing a circular motion like this. In this case, the force which is responsible for this circular motion of the bob is what? The tension along the string, because this is the force. If this, we will take this as the center and this is the radius, the path will be like this. Clear? So if the pendulum execute a circular motion along this direction, then the force which is responsible to change the velocity at each and every instant is what? The tension along the string. So here the centripetal force is what? The tension along the string. Clear? Similarly, if a ball move along a semicircular path like this, okay, this is a semicircular path and the ball is moving along this direction. So at each and every instant, the force which is executing this circular motion is the normal reaction force acts on the ball due to this contact surface. So here the required centripetal acceleration is provided by the normal reaction N. Clear? So in each and every case, if the body is executing a circular motion, then the centripetal acceleration is necessary, and the force which is provided, that required amount of centripetal acceleration is known as what? Centripetal force. And that force may be any kind of force. Here it may be a tension, here in this case it is normal reaction. Clear? So next we are going to study how to calculate the magnitude of centripetal force, because we know for performing a circular motion, centripetal force is most which will provide the required centripetal acceleration. So how to calculate the value of centripetal force for a particular body executing circular motion? So derivation of centripetal force. So for this, here assume a body performing circular motion. Okay, this is the center of the circular path O. And here is two axes along, known as x-axis, and y-axis along vertical direction. Clear? So let at any instant of time, the particle is at point P which is performing circular motion, clear, and the radial vector or the position vector is r vector, clear, and the angular displacement of the particle is theta, clear. So if I am displacing or transforming the x axis and y axis parallelly to this point P like this, so this is x axis, so this axis also x axis, so let it name as x dash, and as this is y axis and parallelly transforming the axis to here, so it will be named as y dash, but both are parallel to x axis and y axis. As this axis is parallel to x axis, so we can take this axis as x axis, and as this y dash axis is parallel to y axis, we can also take this axis as y axis, clear. So at this point P, the radial vector r is along this direction, so I am assuming a unit vector which is along this radial vector like this. Let this vector be ER vector, clear, the unit vector or ER cap, okay, it's a unit vector which is along the radial vector or along the radius or the position vector of the particle P, and at the same instant I am assuming another unit vector which is along the tangent, okay, like this, along this direction. So this is another unit vector ET cap which is along the tangential direction to this position of the point P. So I am here writing the ER is equal to unit vector along the radius, and ET cap is unit vector along the tangent, clear. As ER cap and ET cap are the unit vectors, so I can easily write here ER cap mod equal to ET cap mod, which is equal to 1, because these are unit vectors, so their magnitude is 1, clear. So let at any instant of time the radial vector is at point P or the particle is along OP location by covering a angular displacement of theta, so the radial vector r vector is along ER cap which is a unit vector. So if this angle is theta, so this angle is also theta, because the x axis is parallelly shifted to here and the y axis is parallelly shifted to here. So if this angle is theta, this angle is also equal to theta. So the unit vector ER cap can be resolved into two mutually perpendicular components. So the two components of the vector ER cap, one is along this direction which is taken as what, ER cap mod cos theta, as it's along x axis it can be taken as I cap, clear. Similarly the other component is along y dash, so it will be along this direction which will be taken as what, ER cap mod sin theta j cap, because it is along the positive y axis. So I am writing here ER cap can be written as how much, ER cap mod cos theta I cap plus ER cap mod sin theta j cap, and as the magnitude of ER cap and ER cap is 1, so ER cap vector, unit vector, can be written as cos theta I cap plus sin theta j cap, clear. Big question 1. Similarly, the tangential component ET cap can be splitted into two components. So one is along this y dash direction, okay, and the other one is along this direction which is negative to that of the positive x axis. So as this angle is theta, so this angle will be how much, as this y axis and x axis both are mutually perpendicular to each other. So if this angle is theta, so this angle will be how much, 90 minus theta, clear. So if this angle is 90 minus theta, so what is this angle? These two are perpendicular to each other because this is along the radius and this is along the tangent. So the radial direction and tangential direction are again perpendicular to each other. So this angle will be how much, again theta, clear. So if this angle will be theta, so the unit vector et cap can have two components. One is along this y dash direction and other one is along this, let it be x double dash, which is opposite to the positive x dash direction. Clear? So the component of the et unit vector which is along the y dash direction will be how much? It will be et cap mod cos theta j cap, because along positive y axis the unit vector is j cap. Similarly, the component of the et cap which is opposite to the positive x axis will be how much? Et cap mod sin theta negative minus I cap. Clear? So these two vectors combinedly give what? Et unit vector. So similarly here I can write the et unit vector can be written as et cap magnitude cos theta j cap minus et cap magnitude sin theta I cap. By rearranging it will be how much? As the et magnitude, both are unit vectors, so its magnitude will be 1, so it will be minus sin theta I cap plus cos theta j cap, which will be et cap. Clear? Let it be equation 2. Okay, so the unit vector which is along the radius or radial vector is known as cos theta I cap plus sin theta j cap, and the unit vector which is tangent to the point or tangential to the circular path is given as minus sin theta I cap plus cos theta j cap. Okay. So now the radial vector at that instant is given as how much? The r vector can be written as r vector mod into er cap, because er is the unit vector along the radius. So this implies you can write the r vector is equal to r vector mod. In place of er cap I can write this much, which is equal to how much? Cos theta I cap plus sin theta j cap. Okay, now differentiating both sides, dr vector by dt will get how much? D by dt of r vector mod into er cap, or this implies what is dr by dt? It will be the linear velocity v vector, which is equal to dr vector mod by dt into er cap plus r vector mod into d by dt of er cap. Okay. So this can be written as v vector mod equal to, here the radial vector magnitude is remain constant as the radius, this much length of the circular path is always constant. So this term will be 0. So this implies 0 plus r vector mod into what is e d by dt of er cap. So we already established here er cap equal to cos theta I cap plus sin theta j cap. So by differentiating will be how much? D by dt of cos theta I cap plus sin theta j cap. So this will be r vector mod into, this is d by dt, here theta is the angular displacement which is a function of time, because as time respect this changes with respect to time, so it will become how much? Cos theta with respect to dt, so it will become minus sin theta I cap to d theta by dt. Clear? Then plus what is sin theta? It is also a function of time, so it will become cos theta j cap again d theta by dt. Clear? So now taking d theta by dt common out of the box, it will be r vector mod into d theta by dt in minus sin theta I cap plus cos theta j cap. Clear? So here what is minus sin theta I cap plus cos theta j cap? As we already here defined, the tangential unit vector is minus sin theta I cap plus cos theta j cap. So here this term will become this one. So we can write the velocity vector equal to r vector mod, what is d theta by dt? D theta by dt is the rate of change of angular displacement mod, it will be omega into this term will be how much? The tangential unit vector. So Et cap. So the linear velocity is equal to how much? R omega, where R omega is the magnitude of the linear velocity, and Et cap, where Et cap is the unit vector along the tangential direction. That means we already find out the linear velocity of the particle which is executing circular motion has a linear velocity whose magnitude is equal to R omega, where R is what? The radius of the circular path, and omega is the angular velocity, and its direction is always tangent to the circular path, because this is the unit vector along the tangential direction. Clear? So now we already get velocity, but we have to find out the acceleration. So now again we have to differentiate this equation. Let it be equation 3. Okay, so now differentiating equation 3, we will get what? Again dv by dt will be equal to how much? d by dt of r vector mod omega Et cap. Clear? So this is equal to, here r vector is a constant with respect to time, so this can be written as r vector mod into d omega by dt into Et cap plus r vector mod into omega, again d by dt of Et cap. Clear? Okay, so we will get what? dv by dt, this will be how much? Acceleration. dv by dt, the rate of change of linear velocity with respect to time, is the linear acceleration al, which is equal to r vector mod d omega by dt, the rate of change of angular velocity is what? Alpha, into E tangential unit vector, plus here r vector is constant, so r vector mod omega, again d by dt of what is E tangential, this is E tangential, so minus sin theta I cap plus cos theta j cap. Clear? So now this will be how much? R vector mod alpha Et cap plus r vector mod omega. Now differentiating this term, theta is a function of time, so sin theta will be how much? Have derivative cos theta, again theta will be d theta, so it will be minus cos theta I cap into d theta by dt, again plus what is cos theta? Theta is a function of time, so cos theta has derivative minus sin theta, so minus minus plus will be minus sin theta j cap, again d theta by dt. Clear? So now taking minus and d theta by dt out of the box, it will be how much? R vector mod alpha Et cap plus r vector mod omega, the minus will come out of the bracket, so it will be minus r vector mod omega into d theta by dt, and within the bracket it will be cos theta I cap plus sin theta j cap. So this will become how much? R vector mod alpha Et cap minus r vector mod, what is omega into d theta by dt is omega square, and this term cos theta I cap plus sin theta j cap, it's same as that of the unit vector along the radius, so it will be E r cap. Clear? So the total linear acceleration of a body executing circular motion will be this much, where Et is the unit vector along tangential direction, that means this acceleration is along the tangential direction, and as Er is the unit vector along the radial direction, so this will be the acceleration along the radial direction. Clear? So from this derivation we will get what? The total linear acceleration is equal to A tangential plus A radial. So here A tangential will become how much? R vector mod alpha Et cap along the direction of tangent, and what is A radial? This is a minus R vector mod omega square E r cap. So what is E r cap? It is the unit vector along the radius, but here we get the a radial is negative of E r cap because this is the complete magnitude and this is the direction. That means the radial acceleration is opposite to that of E r cap. That means the radial acceleration must act along this direction. That means on the body towards the center along the radius. Clear? So its magnitude, a tangential magnitude will become how much? R vector mod alpha, and the magnitude of a radial will become how much? R vector mod omega square. Clear? Which is opposite to what? The direction of radial vector or towards the center along the radius. Clear? So if the body is executing uniform circular motion, so here we will get this is the tangential acceleration r alpha and this is the radial acceleration r omega square. So if the body is in uniform circular motion, so as we already studied, in case of uniform circular motion the angular acceleration is equal to 0 because there is no change in velocity, no change in speed, so speed is not changing, so tangential acceleration will be 0. If tangential acceleration is 0, r can't be 0 because it is fixed, so alpha is equal to 0. So this implies a tangential is equal to how much? 0. So the total acceleration a linear will become how much? R omega square. So if the body is in uniform circular motion, so the total linear acceleration will be r omega square, which is equal to a centripetal or a radial only. Clear? So this is the expression for what? The radial acceleration or centripetal acceleration, which is acts along the radius towards the center. So as we know, omega equal to how much? V by r. So this implies the centripetal acceleration or radial acceleration will be equal to how much? R. In place of omega I can write V by r, so it will be V square by r square. So this will be V square by r equal to a centripetal, or this can also be written as r omega square. Okay, this is the magnitude of the centripetal acceleration, but its direction is along the radius towards the center. Clear? So this is the expression what? The centripetal acceleration. So if the body has mass m, if the particle has mass m, then the centripetal force which produces the centripetal acceleration is how much? The F centripetal equal to mass of the body into acceleration, that is centripetal acceleration a c. So this implies the F centripetal will be equal to m into r omega square, or this can also be written as m v square by r. Clear? So this is the expression for centripetal force which is acts on the body along the radius towards its center, or this is the force which cause or provide the required centripetal acceleration which is responsible for the particle to move in a circular path. Clear? So this is the derivation for centripetal force and the centripetal acceleration, which can be asked as a long question in your examination. And from this expression we can also find out, as we know the time period t equal to 2 pi by omega, or this implies you can get omega equal to how much? 2 pi by t. We already established this relation in previous class. So putting the value of omega in this relation, we will also get the centripetal force equal to m r. In place of omega square I can write 4 pi square by t square, and we already know what is 1 by t. The reciprocal of time period is frequency, so this can also be written as m r 4 pi square F square. Clear? So this is also the expression for what? Centripetal force. Clear? You have to remember these formulas for solving numericals. Clear? So what is centripetal force? It is the force which produces centripetal acceleration to performing a circular motion. Clear? So next we are going to study centrifugal force. So what is centrifugal force? So centrifugal force is same as that of centripetal force. The difference is only that centrifugal force is a pseudo force and centripetal, it is opposite to that of centripetal force. So when a body is executing circular motion, okay, if the particle P is performing a circular motion of radius r, then the motion of the particle is considered to be in anticlockwise sense. So when we observe the motion of this particle from a reference frame which is inertial, if a person or observer is standing on a ground and he is observing the circular motion of this particle P, so the ground is at rest, so it is a inertial frame. What is inertial frame? Velocity is constant or acceleration equal to 0. Clear? So as the observer observes the circular motion of this particle P from a inertial frame, so the force which is responsible for changing the direction or giving the required centripetal force is known as centripetal force Fc. Clear? But whose value we already derived, mv square by r or mr omega square. But at the same instant, when a person sits on this body which is performing circular motion, then for the observer which is sitting on this body P, the frame of reference is in motion. So this frame of reference is not at rest, that's why it will become a non-inertial frame. Okay, so during this non-inertial frame, this for the observer on the particle P, the particle P is in equilibrium condition because for the observer the particle will be in rest. But as there is a force which is acting along the radius towards the center, so this particle must move along this direction. So to cancel this force, as for the observer this particle is at rest, another pseudo force or virtual force acts opposite to that of the centripetal force, and this virtual or pseudo force is known as what? Centrifugal force. Whose magnitude is equal to that of centripetal force, but its direction is opposite to that of centripetal force. So centrifugal force is a pseudo force which acts on a non-inertial frame which is performing circular motion. Clear? And its magnitude is equal to that of centripetal force, but its direction is opposite to that of centripetal force. That means centrifugal force acts along the radius but away from center. Clear? So we can write what is centrifugal force. It is a pseudo force which acts along the radius and away from center for a non-inertial frame. Okay, so it's a pseudo force which acts along the radius and away from the center for a non-inertial frame executing circular motion. Okay, if the non-inertial frame is in motion and that motion is to be circular, then the pseudo force which acts along the radius away from center is known as what? Centrifugal force. So another important point, centripetal force and centrifugal force never acts at a time. Okay, centrifugal and centripetal force never acts at a time. Why? Because a single observer can be present at both places at a time. If the same observer is placed in the non-inertial frame, then the observer can be placed in a inertial frame. So centripetal force is the force which is responsible for the circular motion in a inertial frame, and centrifugal force is the force which is responsible for the circular motion in non-inertial frame. But these two forces never act at a time, because a single person can't observe the motion from two different frame of reference at a time. That's why if there is centripetal force present, then centrifugal force is absent. If there is centrifugal force is present, then centripetal force is absent. So what is the example of centrifugal force? So you must observe during the motion in a car, when the car takes sudden a circular turn, the objects or the keys which are placed on the dashboard, they will get a outward force, that is known as what? Centrifugal force. Or when you are grinding something and the lid of the grinder container opens, the content thing within the container splits out, that is due to what? The centrifugal force. It acts out of the center along the radius. Clear? So this is all about centripetal force and centrifugal force. Clear? Both have same magnitude but opposite direction. Clear? You have to remember this point, and they can't act at a time. Clear? Okay, so this is all about for today's lecture. In next class we will study some applications of the centripetal force. Okay, thank you.